This is the GTC 505, an engine testing tool most mechanics don't even know exists, and if they do, they're not using half of what it can really do. It can pay for itself in just a single diagnosis. So whether you're a beginner or a pro, what I'm about to show you can save hours of guesswork and hundreds, if not thousands of dollars. And at the end, I'll show you how you can spot problems like worn plugs, lean engines, and even low compression in seconds. Before we get into the hidden features, let me show you some of the common uses for it. First, to turn on, press the power button, and we're working on a RAM right now, so we're going to select Waste Spark. This is the 5.7. The main thing that most techs use the 505 for is for ignition waveforms. And to get there, we're going to go into mode, we're going to go into voltage and view, and we already select waveform. This is going to show us what we're going to get from an oscilloscope when we're scoping the secondary. So to get a waveform, we're going to place the end of our inductive pickup on the coil, and we can see we have a line there. That line is going to go up and show us our peak kV. We can try another one. It's kind of hard to see the exact reading we're getting, so we can go into view, digital, and now we'll get a numerical representation. So we can see this coil is right around 50 or so kV, right around the same. The key thing to know is that the peak voltage you see here is heavily affected by the resistance in the secondary circuit. So things like spark plug gap, worn plugs, wires, cylinder compression, all of which I'll show you examples at the end. The next most common mode would be burn time. So I'm going to go back into the waveform view, and burn time, if you think of peak kV as the energy required for the spark to jump the gap in the spark plug, then burn time is the length that that spark is jumping that gap. And that tells us a lot about the conditions inside the cylinder. So here we can see we have a burn time of approximately 1 millisecond, and that it's sloping down, and that we have oscillations at the end. Those oscillations come from the coil and indicate that the coil still has some excess energy. Now, if you look at the duration of the entire burn line, we can split this into halves. If we draw an imaginary line across halfway vertically, the left half is going to be heavily influenced by factors outside of the cylinder, and the right half is going to be influenced by what's going on in the cylinder. Now going on ramp time, this is showing us how long that coil is being commanded on. So you can use this to catch intermittent power drops or signal drops. If you had a connection issue, you would see a dropout in this line. So let me see if I can show that to you. So we see we have our coil there. I'm gonna unplug this guy, and we see how it kind of freezes and then drops out. When it freezes like that, it's not getting any more. And if I slightly pull it out, you can see that that command is a lot shorter. So that's the basics of the tool. But here's the thing. The real power of this tool is hidden in the features most techs never touch. Imagine you got a car with a slight stumble, but it's not really happening all the time. So you pop the hood, you check the coil waveform, and everything looks fine. So you're stuck. The problem only shows up for a split second, and if you're lucky, you might see a flicker across the screen before it disappears. That's exactly where the chart function comes in. To use it, press the mode button. We're going to select TAC, then hit view, and we're going to go to chart. Now the tool is going to record the last 276 spark events, and it's going to display them in a graph. If there are any dropouts in the coil that you're measuring, they'll show up right on that graph. And the nice part is you have a long enough buffer that you can set the tool down, snap the throttle a couple times, and still catch it. Just watch out, because if the pickup slips off the coil, the tool will think there was a misfire too. So the chart mode is perfect for catching misfires that only happen once in a while. But sometimes you need to know if one cylinder just isn't pulling its weight compared to the rest. The problem is small changes can be hard to spot if you're just eyeballing the waveforms. And that's where the comparison function comes in. To use it, we're going to click view, go into comparison, and then we're going to click mode, and we're going to select what we want to measure. So for this example, let's click voltage. Now it's set up to record 16 values. When we press the hold button, it saves the last 16 readings and draws a line at the average. Press hold again, and it starts recording into a new sample. You can build up to 16 samples on one screen, which makes it really easy to see the difference between cylinders. You can even compare the same cylinder under different loads to see how it responds. Now that we know how the tool works, I'll show you what a lean engine looks like, what worn plugs look like, how you can even catch low compression right on the screen. And for the pros out there, see if you can spot the problem before I reveal the answer. So I've now induced a fault. Let's see if we can figure out which cylinder it is. Got a couple captures, hold. Hold. And I think we can easily tell what cylinder is at fault here and what the fault is, because we can see our average kV on that cylinder is way higher. What causes the kV to be higher? That's going to be secondary resistance. And what did I do? I just pulled the coil wire a little bit off. So now that's snapped back in place. We're right back on. Press hold. And we can see we're back around the normal value. And we can see our burn time's right around 1 millisecond. We got good coil oscillations at the end there. So spec is 40. We're gonna set it to 39. See, a new one just fits. They have about double. About 15 kV. 15. That is way lower. Alright, got the engine at top dead center. We're doing the leak down test. Cylinder 4 showing 65-ish, or my bad, 55-ish about percent. If we listen to the tailpipe, we can hear air hissing out of there, so we have a leaking exhaust valve. Hope you picked up something new from that. If you want to see the full context behind these case studies and how I use the information in real time to go from one test to the next, click on one of these videos.